You are a veteran of spaceflight. I believe you were on 3 space shuttle missions, a Soyuz mission as well. When you see a rocket of this size taking off from the launch pad, can you give us a sense of what it would be like to be on board this? Because eventually it will be equipped for human spaceflight.
Well, Paul, as Ed pointed out, this is by far the most powerful rocket that's ever launched. And so, of course, it's the largest rocket. But again, its time to achieve orbit is about the same. And so the G profile may be a little more powerful, but I suspect it won't be significantly different than it has been historically. What I experienced on both the space shuttle and the Soyuz, getting up to about 3 Gs or so.
You went to space 3 times in the shuttle program, once on Soyuz, good old-fashioned rocketry on Soyuz. The whole big picture of this, as we've discussed throughout the program, is the reusability factor of the combined Starship system, but the ultimate goal to get humankind back to Mars, to Mars for the first time. I just wondered if you'd reflect on that, what you would need to see to give you confidence in the system that you would get on board it.
You cannot overstate how difficult going to Mars will be. Even as powerful as the Super Heavy is, we're still talking about a mission round trip that's just short of 3 years. And once you leave the vicinity of Earth and you're going to Mars, you cannot turn around. You cannot come back. And so, regardless, I unfortunately think we have got to develop more advanced propulsion technology than exists today.
Colonel McArthur, you say you cannot, overstate how complex this is. It sounds like you have a lot of doubts. Do you think that SpaceX can get there? Is there any other sort of entity that can get there on the technology? And how far away do you think are we from that? And so,
sadly, if you had asked me 10 years ago, I would have said we're 30 years from going to Mars. I was just told a group of folks recently, I think we're 30 years from going to Mars. Again, will we go sooner? I absolutely hope so. Can the Super Heavy and Starship get us there? I think it can get there. I think we can attempt a mission with some likelihood of success, but the risk is going to be extremely high.
Colonel, the interim goal and perhaps more achievable goal is to return to the moon. Do you have a different timeline for when you expect to see that happen?
Oh, absolutely. I think that's achievable within the next 5 years. Maybe even a little less time than that. And I'm not talking about the Artemis II trip around the moon, but I'm talking about the Artemis III actually landing on the moon and hopefully using Starship as a lunar lander. But here's an interesting thing: the hatch that the crew will come out of will be 50 feet above the surface of the moon. Imagine walking back and find out that you have to manually crank your elevator. Your elevator isn't working, and you have to manually crank yourself back up 50 feet. It's going to be one heck of an adventure.
I think I'd just reflect a little bit of what we're seeing on the screen, if that's okay. And we're seeing the Raptor engines on the underside of the Starship spacecraft portion. The aim throughout this mission is to one of the aims of goals of the mission is to deploy simulator Starlink satellites, and I say that with the note that the payload potential of Starship is about 200 metric tons. You talked about the technology, and I think that's worth lingering on a moment. The Raptor engines that make up the Starship craft and system, they burn methane and have liquid oxygen as the oxidizer. I just wondered, if you could talk a little bit more about what sort of propulsion technologies you were referring to that you see as more appropriate or likely to make humankind an interplanetary species.
So I'm referring to things like solar electric, nuclear electric, where we now we will need the big engines to get to orbit and to get our Mars craft built on orbit, either cislunar orbit or in low Earth orbit, and then accelerate from there. And something like solar electric propulsion, or more likely nuclear electric propulsion, where instead of having really big engines producing hundreds of thousands of pounds of thrust, we produce less thrust but are able to keep the engines operating continuously for days at a time.
Colonel McArthur, just bear with me a moment. We've got some breaking headlines from SpaceX, which is that the booster, we had booster demise, essentially. It exploded, for want of a better expression, en route to landing. And SpaceX has confirmed that via their feed, but we're still getting the live images, which are broadcast from the Starship spacecraft using the Starlink technology, by the way, on our screen. So we can do a post-mortem later on what happened with the booster, but reminder to the audience that it was reused. It had flown on the 7th test flight of Starship. Let's end with this. What can you tell us about how your industry, your peers and those that went with you and before you to space, view and evaluate the work that SpaceX has done to change launch and space travel?
So I think what SpaceX has done is simply brilliant. And it's not so much the technology, it's how they approach learning. That they put an incredible amount of instrumentation on these spacecraft, and SpaceX launches them. And if they fail, they very quickly are able to pinpoint the area that they need to address, the problems that they need to correct, and then they try again. And that is something that NASA simply in the political arena is not allowed to do. And so I think that is the strength in the commercial spaceflight industry, that they are able to accept a risk of a loss of experimental hardware. They're allowed to test to failure, which government agencies are rarely are able to do. And so, I think it's just simply a brilliant business model.